Hello, and a very warm welcome to all of you. Today, we're going to start with another aspect of algebra. We've already covered a topic in which we discussed how to add and subtract algebraic terms or algebraic expressions. Today, we are going to be covering multiplication of algebraic expressions. Before I start the topic also, you need to be having knowledge of a few concepts in place which you have learned in your earlier classes. Let's just have a very quick look at them. The first up on the board is multiplication of integers. I think all of you should now be knowing that if you multiply a negative integer into a positive integer, you're going to get a negative. A positive into a negative will also give you a negative sign finally. A negative into a negative will give you a positive, and there is no problem with a positive into a positive. That's always going to give you a positive. So this knowledge of integers, please keep in mind when you start your multiplication of algebraic expressions. The next thing that you need to keep in mind is expanded form of an algebraic term when it is written as an algebraic term. So suppose I take this 2 into x into x into x. How many powers or how many times do I have x written? 1 time, 2 times and 3 times. So that in all is an x cube. Minus 2 multiplied into x cube, the whole term will then be minus 2x cube. Right? Now if I look at another such example, I've taken 3 into one variable a into b into b. So I've taken 2 b's here. So what is the power of b going to be? 1 and 2. So that's b squared and 3ab squared. This is what you're going to be getting when you are multiplying and writing it in a concise form as an algebraic term. Coming next to the rule of exponents. Remember when you did exponents, when you had to multiply a number with the same base and different powers, what happens to the powers? The powers get added. So if I have to take an example, x cubed into x squared is nothing but x raised to power 3 plus 2, which is x5. Where did I get the 3 and 2 from? 3 from here, 2 from here. So 3 plus 2, which is 5. Look at another example. xy squared into y squared. X will remain as it is. The powers of y will get added. So that's y raised to power 2 plus 2, which is nothing but y4. Is that okay? Another thing, when we were adding and subtracting algebraic expressions, it could only be done when the terms are like, I cannot add an x square to an xy and get 2x square y, or I can't get 2xy. Let's just see. Like suppose I had one expression as xy plus x square and another one as minus 3xy. Now this should have been written here. Now in this case, I only have one x square term, so it remains as it is. Look at your xy terms. There's a plus 1 xy without any numerical coefficient automatically means it's a plus 1. So plus 1 xy, and here it's a minus 3 xy. So combined together, it's a plus 1 and a minus 3, which gives you a minus 2 xy. The x square term is independent of the xy terms. I can't add it to the xy term, so it remains as it is. So your final answer is x square from here, and these two together have given you a minus 2xy. There's another thing in which sometimes children confuse, and that is why we are always insisting that the terms should be written in alphabetical order. Now look at these two, mn square and n square m. Do you think they are like terms or they are unlike? If I write them alphabetically, let's see what's going to happen. If I look at the English alphabet, it's OP. So I have mn. So this here becomes 3mn square, and here this also becomes mn square. So this is minus 4mn square, which is nothing but 3 minus 4 mn square, which actually gives you a minus 1 mn square. And as I was telling you, if you have only 1 as your coefficient, you do not need to write that 1. You can simply write this as minus mn square. Is that okay? So this was what we had done when we were doing algebra. Now let us talk about how to multiply. All this was essential for you to be able to step into your topic of multiplication of algebraic expressions. Let's quickly move in. So the first kind of multiplication that we are going to take up is monomial by monomial. What is a monomial? A monomial is nothing but a single term expression. You don't have two terms. And how do I define a term? There is no plus minus sign in between the different factors of the term. Like so, if I look at minus 3x, in itself, 3x is a term because I don't have a 3 plus x, although I don't have a 3 minus x. Minus 3x, the minus sign is applicable to the whole term, right? So the term itself is minus 3x and this term is 9y. So there are two monomials. Now when I am supposed to be multiplying a monomial into a monomial, I need to multiply the numerical quotient into the numerical quotient. So that gives you a minus 3 into a 9. So what's my first thing that I've done? I've done numerical coefficient into numerical coefficient. And then I've multiplied, look at the green marker, the variable part x into y. So that's going to give me an xy. So the second thing we did is multiply the variable parts or the variable factors. So this and all is going to actually give you minus 3 times 9 is minus 27 and this then is xy. Easy enough? Not a problem. Now let's look at a second example. This does not have any variable part. I do have a numerical part, so 7 into 3, that's going to give me a 21. And xy is going to be multiplied with, I don't say nothing. I'll assume that there is a 1 here. So I'll assume that is basically a 1 here, it's a silent one. So this becomes xy into 1 and so that becomes xy. Right? It's not as though you're not going to multiply it, you're going to leave it at all. So this is xy into this one because there was nothing here. When there's nothing here, we don't assume it to be a 0. If I say 3, it is the same as 3 raised to power 1. If I say xy, it is the same as 1 xy. So that 1 is always a hidden factor. So then I say 7 into 3 and xy into 1, that gives you a 21 xy. Right? Now let's have a look at a third example. And now I'm quite sure you would generally be knowing what to do. I multiply the coefficients into the coefficients. So that's 9 and here the coefficient is minus 7. 9 into a minus 7 gives you minus 63. Now I have two kinds of variables. I have x square and the x. What is the power? Okay, I'll just write this. This is x square into x. And please remember, I'm not putting in any kind of signs in between. The bracket here is to indicate that this is going to be multiplied into this. And let's look at the y's. It's a y into a y. So this becomes minus 63. Remember, our powers of exponents with the same base, if two numbers are multiplied, the powers get added. So I just told you a second back, x means nothing but x raised to power 1. So you're going to be saying 2 plus 1, which is then x raised to power 3 and y raised to power 1 and y raised to power 1. The powers get added to give you a y square. Good. So this is how you add monomials. Now this knowledge is going to be used in multiplying a monomial and a binomial. Okay. So next up for you is monomial by binomial. And here I am going to be using the distributive property which you have learned in your earlier classes. What would it say? A into B plus C is nothing but A, B plus A, C. That's A gets multiplied into B. It also gets multiplied into C. Let's take it with the help of an example. Suppose there are, say, 8 girls in a class and 12 boys in a class. Right? On an occasion, the teacher needs to distribute some properties to them, some toffees to them. And so she says that I'm going to be distributing 3 toffees each to the girls and to the boys. So let's see what's going to happen. So she says I'm going to be distributing 3 into 8 and also 3 into 12 because she is distributing 3 to the girls and 3 to the boys. Another way of doing it could be I just add up the total number of children, 8 girls and 12 boys, that gives me 20 children in all, and 3 to be given to each, and so that's 3 into 20, which is 60. One way of doing it is that. Another one, to the girls, I'll give 3 into 8, which is 24. And to the boys, I'll give 3 into 12, which is 36. And totally, again, I'm going to be getting 60. So this is the thing which I'm going to keep in mind when I start doing my monomial into binomial multiplication. So let's start with a very simple example. Let's take this example. Here I take minus 2a. I'm going to be multiplying it into 4ab plus 3b square. Remember this here, the first one is a monomial and this has two terms, so it is a binomial. So I will then multiply, as we've done here, I have said that a can be multiplied into b to give you an ab, a can be multiplied into c to give you an ac. So I am going to be multiplying minus 2a into the first term, which is 4ab. Again, minus 2a from the monomial, and so that is minus, and in between, what was the sign here? That sign will remain the same as it is. So this is a plus sign in between, so the plus sign comes here. And again, I am multiplying minus 2a into the second term here was 3b square. Please keep in mind that whenever you have a negative sign, please put it into a bracket so as to avoid any kind of confusion. So we've already learned how to multiply a monomial into a monomial. Numerical coefficients, minus 2 into 4 will give you a minus 8. A is 1 here, another a 1 here. So what is the power of a going to be? It's going to be a square. There's no other b, so that's b. Let's look at your second term. In the middle, I have a plus sign. Numerical coefficients, minus 2 into a 3, that's going to give you a minus 6. So for the time being, I'm going to write this as minus 6 here. And ab square. A was from the first term, b square was from the second term. But this is looking slightly unresolved. So I'm going to do a plus into a minus, which will obviously give you a minus. And so my final answer is going to be minus 8ab square minus 6a, sorry, it was a square b, and this is 6ab square. So have you understood? What did we do? We used the distributive property and we multiplied the monomial into both the terms separately. Minus 2ab was multiplied into 4ab, minus 2a was also multiplied into 3b square. And you know how to resolve a monomial into a monomial. That's numerical part into numerical part, variable part into variable part. Is that okay? This is how you want to get your answer for a monomial into a binomial. We'll just do one or more example to cement the concept. So there's one more up for you, monomial into binomial. Again, the monomial into the first term, monomial into the second term. But in this, I have taken the sign in between as minus. So we'll have to be careful when we finally split the terms, right? So this is minus 8mn. What did I tell you? Please put it into a bracket. And this is 3mn square. Sign in the middle here is minus, so minus comes here. And minus 8mn from the first term. You've already taken care of this minus sign, so please do not write this as minus 4m. This, if you write this as minus 4m, this minus has already been taken care of, so you are not going to write minus all over again. Please keep that in mind. This is a mistake which a number of children do make at times. So minus comes here and this then is left without the sign, and that is 4m, right? So now when you multiply coefficient into coefficient, that gives you minus 24. Look at the m's. You've got one m here, another m here, so that becomes m squared. You've got one n and two n's. So 1 and 2 together give you a n cube. Now look at your signs here. Minus into a minus. That's going to give you a plus 8 into 4, that's going to give you a 32. M, one here, another one here, so m squared, and you have a single n, which is this. So that's going to be your answer. 2, 3 things. Minus sign always in a bracket. Write your terms alphabetically. Also, if there is a minus sign in the middle, you've already taken care of it here. You do not need to write it all over again. Is that okay? So that was another one where you had a monomial into a binomial. Now we'll shift into binomial into binomial, right? So here on the board, I have a binomial which is 2 terms into another binomial which is another 2 terms. So I'm going to use the concepts which we've been learning. Now this time I'm going to split this binomial first into 2 terms, and I'm going to then move as a monomial into binomial. So this I'm going to keep separately for the second step. I have split the first binomial, and so this then is the first term of the first binomial into the entire second binomial. I'm still using distributive property. Now, I've taken care of 3a being multiplied with 2a plus b. What is my next term? It is plus 2b. So, that plus 2b then gets multiplied with again the entire second binomial, and so that is 2a plus b. Now, I'm going to use the same thing which I did monomial by binomial. I'm going to multiply first term into first term, monomial into first term, monomial into second term. So, this is then going to become 3a into 2a plus 3a into b. That is actually my first expansion here. Then I'll look at my second expansion. So, that becomes 2b into 2a plus 2b into b, right? Now, it's very, very easy. I know 3a into 2a is to be multiplied numeric into numeric variable into variable. So, that becomes 6a square. 3a into b, that's going to give me a 3ab. Now that I am done with all my multiplication, I can safely remove my brackets. I don't require them any longer. So, this is 2 into 2, 4. BA, should I write it as 4BA or should I write it alphabetically and write it as 4AB? So, I'll write it as 4AB, and the moment I write it as 4AB, I will see that there is a corresponding term of AB. Earlier also there is a corresponding term here also, and I can easily add or subtract whatever the case may be. I still need to multiply 2b into b, so that is 2b squared. So, my final answer then is going to be 6a squared. 3ab and 4ab together, they're going to give me 7ab. And finally, 2b squared. So, any problem? I guess you should have understood. Again, just a recap, I'm going to split up the binomial. Now, you may say that, why did I split up this one? I could have split up this one also. It is not going to make any difference. But then whichever one I split, I'll just move that in the front. You know, whether I multiply 2 into 3 or write 3 into 2, it's going to give me the same answer. So, I write this, I split it up, I multiply the first term of the first binomial into the entire second binomial, the second term of the first binomial into the entire second binomial, and I know 3a into 2a, 3a into b, 2b into 2a, 2b into b, and that's going to give me my final answer for a binomial into binomial. We'll just do another example now that you have learned the concept. So, moving on, I've taken another example here this time. Just to give you that variation, I put in minus signs in both my binomials. So, the first one is going to be, again, I'm going to be splitting it up and splitting it up before the second term and taking the sign of the term alongside. So, I multiply 2a into the entire second binomial. What's my second term here? It is minus 3b. So, I put minus 3b into 2b minus 7a. Does that make sense? Okay. So, now this, I know monomial into binomial. I'll multiply this term. I'll multiply 2a into 2b. I'll also multiply 2a into 7a. And so that's going to give me 2a into 2b is going to give me a 4ab. 2 into 7 is going to give me a 14, but there's a minus sign. So 2 into minus 7, that's going to give me a minus 14. 1a, second a square. Right? Now coming to the next one. I have a minus 3b. Please keep in mind that you have to take this with its sign. So minus 3b into plus 2b. Minus 3 into 2 is going to give you a minus 6. B into b is going to give you a b square. That's 1b and another b. So that's b square. Now I come to this last multiplication, which is minus 3b into minus 7a. Minus 3 into minus 7 becomes a minus into minus gives you a plus. So that is plus 21. And what do I have? Again, B is written here first, A is written here, B, A. But then I told you write it alphabetically, so that becomes 21 AB. Now, if I try and rewrite it, can you see there's a AB term here, there's an AB term here? Yes. So we are going to try and combine those two terms. Another thing, which kind of term should I write first? Should I write the A square, the B square, the AB term? Always try and write the pure terms first. Also, again, by writing the terms, look at the descending degrees. If you had had something in A cube, that term would have come first. But here, all my terms have two variables. A into A, 2 variables. B into B, 2 variables. A into B, 2 variables. So in that case, I write my pure terms first, and then in that also alphabetically. So my first term would be minus 14a square, next minus 6b square, and a plus 4 and a plus 21. Remember, without a sign, it is always regarded as a plus. So plus 4 and plus 21 is going to give you plus 25 AB. That's going to be your answer here, right? So that's how you're going to be doing a binomial into a binomial. Let's move a step further. You may also be having a sum in which you need to multiply a trinomial into a trinomial. Let's have a look at that. So I'm going to take an example where you're going to be having your first trinomial as A plus B minus C, and that needs to be multiplied with A minus B minus C. Same thing, I'm not going to do much of a difference. I'm just going to split it this time not into 2 terms, I'm going to split it into 3 terms. This is going to be your second and this is going to be your third. Right? And I will multiply each one of them separately with the second trinomial. So let's do that. This is A from here being multiplied into the entire second trinomial, A minus B minus C. What's my second term here? Plus B, which I will multiply here. Again multiply with A minus B minus C. What's my third term here? It is minus C. So I multiply minus C into A minus B minus C. Let's multiply monomials into single terms. A into A square, A into A square, A into minus B and A into minus C. So that's going to give you A into A is A square. A into minus B is, because A without a sign is a plus. So plus A into a minus B is going to give you a minus AB. Plus A into minus C is going to give you a minus AC. Moving on, now this is my first expansion. Let us look at the second one. B into A, BA, which again I will write it alphabetically, and that's going to give me a plus AB. Plus B into minus B, a minus B square. A plus B into a minus C, minus BC. Okay, again the second one accomplished. I'll close my square bracket. Come to the third one. This time, please remember, it's a minus C, which we picked up from the first trinomial. That's going to be multiplied into the entire second trinomial. So minus C into A would actually, I'm going to put a plus sign in between. So minus C into A will give you a minus CA. Alphabetically, it will be minus AC. Minus C into minus B, minus into minus a plus. This is going to become a BC. Minus c into minus into minus is a plus, c into c, one c, another c, so that's going to be plus c squared. Now let's try and collect. First write our pure terms. I have in a squares, I just have one term, a square. In the b term, b square here, nowhere else. It's a minus b square. And so that I don't make mistakes, I for the timing, I'm going to cut my a square here. I'm also going to cut my b square because this is a term which I've already used, so that I do not repeat it again. I'm going to do that. And please remember, I keep a plus sign in between, taking the minus sign inside so that it does not create a confusion. Your c square is again with a plus sign. Let's look at our AB terms. I have a minus AB here. I have a plus AB here. So the minus AB and the plus AB are going to cancel. Wherever I'm cancelling, I'm using a double slash. Okay. I have a minus AC and a minus AC. That's 2 minus AC. So that's minus 2 AC. I've taken care of this. So I'm going to write minus AC and minus AC done. Now the only term I'm left with is minus BC and a plus BC. Minus and plus will again cancel, and again for cancellation a double slash, and so you can see all the terms have been picked up. I forgot to cancel C from here, and so my final answer is going to be a square minus b square plus c square minus 2ac. That's the answer. Is that okay? So this is how you go about trinomial into trinomial also. So the next example of a trinomial into a trinomial is this one. Here I put in two minus signs and here I put in the plus sign. Remember 2 minutes back I was telling you that if I'm not comfortable splitting this term, I can split this term. The plus signs are always easier to deal with, so I'm going to get this term in the front, this expression in the front, and I'll split this one. So I'm going to rewrite the entire sum. And why is that possible? If I say 2 into 3 is the same as 3 into 2. So whether I write this particular expression in the front or write this expression in the front, my final answer is still going to be the same. But this is going to make life definitely easier, right? So this is x plus xy plus y squared, and this is going to be multiplied into x squared minus 2xy minus 3y squared. Again, as I told you, I'm going to be trying to split up things, and this is plus xy as one term, and the second term is going to be, the third term, sorry, is going to be plus y squared. So I multiply the first term, which is x into x squared minus 2xy minus 3y squared. Where did I get this all from? This is the second trinomial. I multiply the second term, which I have split, xy into x squared minus 2xy minus 3y squared, and I am also left with the third term here, which becomes plus y squared into x squared minus 2xy minus 3y squared. Have I been able to take the entire thing? I have multiplied x to the trinomial, xy to the trinomial, y squared to the trinomial. You would have noticed, had I got a minus sign, I'd have to play a lot with the minus signs. The plus is always much easier. So I multiply and I keep writing things in brackets. X into x squared, that's 1x and 2x, so that's x cubed, minus the numerical quotient remains 2 because without a numerical quotient this is 1. So 2, 1x, a second x, x squared, y. Here I do not have an x, so this becomes minus 3xy squared. I finished the first set, I close my square bracket. Now looking at the second one, one coefficient, so the numerical part remains 1 into 1, which is 1. 1x, 2 x's, so x cubed, y. Remember, x squared is definitely not 2x, so please do not make such mistakes when you are multiplying. You have to talk about adding powers, you do not need to add the coefficients. So when I am multiplying x raised to power 1, x raised to power 2, the powers get added x cube y. Now I'm trying to multiply xy into minus 2xy. So that is the numerical part 1 into minus 2 gives you a minus 2. X into x, that's power 1, power 1. So that's x square. Y power 1, y power 2. So that's y square. Come to the third term, which is xy to be multiplied into minus 3y square, and that gives you minus 3 x. There is no x here, so x remains with a single power. Y power 1, y power 2, so that becomes a y cube. I'm done with the second set of multiplication. I move on to my third set. Now coming here, I need to multiply y square into x square. There's nothing common. So this becomes x square y square. That's a coefficient 1 into a coefficient 1. So there's no difference. Now coefficient 1 into a minus 2. That's going to give you a minus 2. X is single x and y power 1 and y power 2 become y power 3. Is that okay? So we are going to write that. So this here is then going to become 2x y cube. This is a minus sign. From where did I get the minus sign? Because this is plus 1 into a minus 3. That gives you a minus 3. Now y, this has a power of 2. Y, this has a power of 2. So this becomes minus 3y4. Right? Again, I end my square brackets. Do you agree that I finished all my multiplication? From here, I've got 1, 2, 3 terms, 1, 2, 3. On multiplying 1, 2, 3, 1, 2, 3. And here, again, I've got 1, 2, 3. So, you understand? For each of them, I'm going to get 3 terms. And in all, as of now, I've got 9 terms. Now comes the part where I need to see which are my higher powered terms. I will put them in the beginning. And slowly, we'll try and cancel out the common terms. Okay. So, what is the highest power? This is cube, 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 power 4, power 4, power 4. And again, I have a power 4, power 4 and a power 4. So, I'm going to try and write all those terms first. So, this is x cube y, which one have I picked up? This is this one from here. Okay. Do I have any other term of x cube y? X cube y, x cube y, none. So, this is as it is. Thereafter, I write my minus 2x square y square. Remember, these are only power 3, so that's not a problem. Do I have another term of x square y square? Yes, I have, and this is plus x square y square. So, I use this also, so I'm going to write this out, right? Now, coming to the next power 4 term, that is minus 3xy cube. I have another xy cube term, and that is minus 2xy cube. So that also I will strike out alongside, and I am now left with only one term of power 4, which is minus 3y4. I hope you understand how am I calling them power 4. If I look at this, x1, 2, that's x square, y1, 2, that's y square. So that's 4 powers together, again x square, y square, and this is how you get it. Now I'm going to come to the power 3 terms. So I have a plus x cube, a minus 2x square y. Do you think x square y and xy square are similar, are like terms? No. This has x with the power of 2, this is y with the power of 2. So I'll have to write them separately. And so this is minus 2x square y minus 3xy square. So then this becomes x cube y minus 2 and a plus 1. What does that give you? Minus 2 and plus 1 integers. You take the difference, you take 2 minus 1, and you then put in the sign of the bigger number, which in this case is minus. So this becomes minus x square y. So I have proceeded up till here. Minus 3 and minus 2, they are the like terms, xy cube, xy cube. So that gives you a minus 5xy cube. That also done. So I have moved up till here. After that, I am left with minus 3 by 4. the plus x cube minus 2x squared y and minus 3xy squared. So you were able to club these two terms and club these two terms. So out of those 9 terms, 2 terms have vanished. You should be having 7 terms to cross check. 1, 2, 3, 4, 5, 6, 7. And that is your final answer. I hope I have been able to throw some light on this topic, and you should now be feeling more comfortable in multiplying monomials with monomials, monomials with binomials, binomials with binomials, and finally trinomials with trinomials. So I think we've exhaustively covered this topic. For any difficulties or any kind of questions that you need to ask me, you can get back to me. My numbers, I also take classes. They go by the name of LearnMate classes. I have a YouTube channel by the same, and these are my numbers, which are 77380 21600, and the other number is 98675 50621. You can get back to me on any one of these for classes or for doubts. Thank you.